Let's get crazy with this one. Okay. What do we see? We see a logarithm, a natural log, right? I could just as easily have written log base e instead of ln, right? These are interchangeable notations. It's just less writing if I use ln. Okay. So keep that in mind. Ln represents the natural or the log of base e. Now, inside this log, we have this quotient. Okay. And again, there's no parentheses here. Okay, there's a whole lot going on. There's a radical, there's exponents. Okay, there's binomials. It's nuts. So keep in mind what we're looking for. The first thing we want to do is we want to get rid of any radicals, because we are in the universe of exponents, right? Natural logs, logarithms, exponents, everything should be written as an exponent, including this. So whatever is under this radical, this x squared minus 2, I'm going to write that now to the 1/2 power. I need the parentheses here because this entire binomial is underneath the radical. So this entire binomial has to be raised to that 1/2 power. Okay. So now I'm here. Now, are there any exponents that are exponents of everything here, right? There are lots of exponents here. There's 4 different exponents in this problem, but none of these apply to everything, right? So I'm not bringing any of these down in front of this logarithm as it currently stands. Okay, so I'm looking inside and I see a quotient. So the first thing I'm going to do is I'm going to take the numerator, I'm going to put it in 1 natural log, and I'm going to create the difference of 2 natural logarithms, right? The log of a quotient becomes the difference of 2 logs. Okay, now I'm looking in here, and once we get to here, it's really just left to right. Okay, so let's look at the first logarithm. Inside this logarithm, are there exponents that are the exponents of everything we see? Like here's an exponent, here's an exponent, here's an exponent. But this 3 only applies to this x. This 2 only applies to this x, and this 1/2 only applies to this. It doesn't also apply to this term. So none of these exponents are coming in front of this logarithm. But inside, I do have a product. So that product becomes the sum of 2 logs. So now I've got the natural log of the 2 pieces of that product. Okay, minus, I've still got this guy. But again, we're working left to right. We'll get to this logarithm after we've handled all our business here. Okay, so now we look inside this log. Are there any exponents here that are the exponents for everything inside the log? Yes, because the only thing here is this 1 power. So that 3 is going to come down in front. Okay, and that's it. We have no more products. We have no more quotients in here. Now let's look inside this log. We have a 2 and a 1/2 at the exponential level. The 2 only applies to the x. The 1/2 applies to everything here. So that 1/2 is coming down in front of this logarithm. All right, so we're here. Minus, now we can finally talk about this. Okay, what do we see? We see an exponent for everything here, everything in this binomial. So that 2 is coming down in front. And then we have x plus 1. Now let's go back through. We already took care of this one. Inside here, we have a log with a difference inside. Okay, you do not get to distribute logarithms into binomials, okay, into a difference. We can expand if there's a product, but we can't distribute logarithms into a difference. Why, do you ask? How many times have we talked about why you can't distribute an exponent into a binomial, right? This is not x squared plus 4. No, 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 no. We've said many, many times you cannot do this. And logarithms are exponents. So we cannot distribute logarithms into binomials. There's not, as much as you want, there's nothing you can do with this now. Same thing applies over here. So we would be done with this problem. There's no more exponents, there's no more products, there's no more quotients for us to handle inside any of these logs.